Hey guys, okay, so I want to talk about 7.5, which is our compound events. In some vocabulary, a simple event describes a single outcome. A compound is two or more simple events. Now, we have a mutually exclusive event, which says it cannot both occur in the same trial of an experiment. So an example would be if I am rolling a number cube, I'm only going to roll it once. What's the probability that it will be a 1 and a 2? Can't happen. I only rolled it once, so it's either or. Okay, so that's mutually exclusive. They can't happen at the same time. Inclusive events, they have one or more outcomes in common, so they share something. So whenever we see these symbols, okay, that's our union. Union means or, we add. And I made a little grid down here to help you guys, okay? If you see the symbol, you know that's a union symbol. It means or. When you see the word or, we add the probabilities. This is our intersection symbol. When we see this, we know it's and when we see the word and, I know I'm going to multiply. So I want to go over some examples just to see this working out. Okay. A group of students is donating blood during a blood drive. A student has a 9 out of 20 probability that having type O blood and a 2 out of 5 probability of having type A blood. What is the probability that a student has type O or, okay, right there, that or, I know I'm adding, type A, okay? So first of all, this is mutually exclusive because you can only have one blood type. You can't have both. So the probability of type O would be 9 over 20. Okay, they told us. The probability of type A is 2 over 5. We cannot add fractions until we get a common denominator. So I know 5 goes into 20, so I'm going to make the denominator 20. 5 times what is 20? I'm going to multiply by 4 and you get 8. And we get 17 over 20. Which is your answer. Okay, each student casts one vote for senior class president. One of the students, 25% voted for Hunt, 20% for Klein, 55% for Villa. A student from the senior class is selected at random. What's the probability that a student voted for Klein or Villa? So Klein had 20%, Villa had 55%. Well, 20 and 55 gives me 75%. It's as easy as that, guys. All right, find the probability on a number cube. Okay, so our number cubes are 1, 2, 3, 4, 5, 6. Those are our faces on a number cube. What's our probability of rolling a 4 or an even number? Well, rolling a 4 would be 1 over 6. There's only one 4 out of 6. An even number, you could get a 2, a 4, or a 6, which is 3 over 6. But then you have to ask yourself, is there anything shared between these? Well, isn't 4 an even number? So I counted 4 for this one, but I counted 4 for this one. So I have to take 1 away. I don't want to count it twice. So that's going to give us 1/2 as our answer. So if you're representing something more than once, you have to subtract it. So you always want to ask yourself, okay, well, is 4 an even number as well? All right, good luck, guys.